We all love space, don't we? Endless, mysterious, and powerful. But did you know Linux has its own kind of space right inside your computer? Here's the first world, the user space. This is where your application live, the program you open and the commands you type. Every app from your terminal to a web browser lives here. But they cannot directly reach the hardware. They need a safe passage. Welcome to Kernel Space, the powerhouse of Linux. Hidden, complex, and secure. This is where the real magic happens. Inside kernel space, we have memory management tracking every byte, network stack handling data packets, device drivers talking to hardware, process management juggling all running programs efficiently. Now imagine a bridge connecting these two worlds called system calls. We all know that every application needs to interact with the hardware, whether to read or write a file on disk or using memory. But apps don't touch the hardware directly. Instead, they cross a kind of bridge into the kernel world where everything is managed safely, securely, and efficiently. Think of it as a controlled gateway that gives apps the power they need without risking the system. Okay, enough of theory. Let's see some action. A quick question. How can I verify what is running in user space and what is running in kernel space? When I run ps-ef, I see two types of entries. Ones that start with a / and others inside square brackets. Processes starting with / run in user space, while those in square brackets belong to the kernel space. But now, let me find process ID of my own shell. ps-ef pipegrep $. Here it is, /bin/bash. Notice it's not inside brackets. That means my shell is running in user space. If I run ls-l in my shell, which is in user space, it lists all files and directories from the disk, meaning it's talking to hardware. So how does a user space application like ls talk to the disk safely? Through system calls, the bridge between user space and kernel space. But where are system calls? Let's find out using strace. So strace ls space -l should tell us what is happening under the hood. Yucks! The output looks messy, but hold on, it will make sense soon. Let's focus on very first line. Here, execv is a system call. Its job is to launch a program. In this case, our shell is asking the kernel to run ls command by giving its full path. Remember, all system calls has a specific job. I always believe in three questions: how, why, and where. How tells us how the technology works, the steps, the mechanics, and you just saw that with system calls crossing the bridge. But why? Why do we need separate spaces and system calls at all? Because separating user space and kernel space is crucial for security and stability. If applications could directly access hardware, a simple bug could crash the system, or worse, attackers could exploit it. By keeping user and kernel space separate and using system calls, Linux ensures apps can only do what they are allowed, preventing crashes and attacks. And where? Where do you see this in action? Every command you run, every process in Linux, containers, Kubernetes pods, or production workloads, anytime an app talks to hardware, these spaces and system calls are at work. Before you learn from anyone, always check their credibility. You can verify mine on LinkedIn. Our mission is to teach practical concepts on technologies listed on screen, making you ready for both interviews and real-time troubleshooting. For more information, check the description below.